This is the demo for Lab 2. You'll be using data from 3.5 and from 4.2. I'm going to use data from a different problem, and it'll be the data from 4.2 number 22. I'll click on the SC link to open up that data. We'll be doing some basic sample statistics on wind speed for starters. So I'll go to Stat, Summary Stats, Columns, and we'll select wind speed. And I'll need the 5-number summary, which includes range, min, max, and first and third quartile. I'm holding the control key to select multiple options here and compute. And so I get my 5-number summary here. And don't forget to save all of your results as you go. Now the next thing we'll need is a box plot. So we'll go to Graph, Box Plot. And I'll select wind speed and make sure that use fences to identify outliers is checked. It should be checked by default, and then compute. And what we see is a standard box plot, and we do not see any outliers here. If I save my result here, then I can make the next modification and save again to get both images. So I'm going to include the value 150. I'll add the value 150. I think in yours it'll be the number 45, but I'm going to add 150, which is significantly greater than the maximum. And then I will refresh under Options, and you can see the change in the graph shows the outlier as a point beyond the box plot on the high end. And again, we can save this new image. So then we have the original box plot and this new image saved both. Next, what we're going to do is some regression and correlation procedures. And so I'm going to take out that extra value and I'm going to close up my results there so I don't have a cluttered screen. The very first thing you need is a basic scatter plot, and that would be Graph, Scatter Plot. You'll first need to select the X variable, atmospheric pressure, also known as the independent variable or the explanatory variable. The Y variable you'll need to select, for me it's wind speed, and that is also known as the dependent variable or the response variable. That's all I'm going to change here and just say compute. And this just gives us a general visual, and it indicates that we probably have a negative linear correlation here. Things line up fairly nicely. The next thing we'll do is we'll do a basic linear regression, a simple linear regression. Go to Stat, Regression, Simple Linear, and this will allow us to numerically verify that regression. So again, our X variable, atmospheric pressure, Y variable, wind speed. You can ignore the hypothesis test section for now. We'll learn more about that later. And we'll just need to make sure that fitted line plot and residual index plot are both selected. Again, use the control key to select multiple, and then compute. Now notice we have 3 results here in one block. So we have a few important things. It's pretty cluttered, so a few important things. Regression equation. So this is our linear regression equation. We have sample size of 20, and we have the correlation coefficient here. So while we're still in this screen, let's remember to save, and you will need to scroll through each of these. Here's our scatter plot with the overlaid linear regression line, the least squares regression line. Go one more and you see the residual index plot, which in this case is fairly random, which indicates that a linear correlation or a linear regression is appropriate. We don't have any reason to suspect it's not based on the residual index plot. And you will need to save each of these separately, so make sure you save all 3 of these separately. Now we will, let's look at the correlation coefficient. You'll need to compare this value to the critical value in Table 2. For a sample size of 20, let's go back to our textbook, and we'll go to Appendix A, the Tables area. We have Table 1, and we'll go one more page here in Table 2, Critical Values for Correlation Coefficient. For a sample size of 20, we see a correlation coefficient of 0.444. Now you'll notice here The absolute value of our correlation coefficient is in fact greater than the critical value of 0.444, which indicates that a linear relationship is present. So we are seeing a linear correlation. The next thing we're going to do is we'll work with our regression equation a little bit. So I'm actually going to copy this to the clipboard so that I can create a report. So I'll right click and copy, and I'm going to create a report. I'll go to statcrunch.com. Under my StatCrunch reports, I'll create a new report. I'll give it a title, and I'll make sure I share with everyone. And then of course, I'll need to answer all of the questions here. But in particular, I want to talk about the regression equation. I'm going to do Control-V in order to paste my regression equation. I'll replace the wind speed with the variable y and atmospheric pressure with the variable x. So now we can see our linear equation here. In order to make predictions, for example, if I wanted to predict the wind speed for an atmospheric pressure of 950 millibars, what I would do is plug the value 950 right in where the x is and make my calculation, and my predicted y value, if we go back here, let's look at our linear equation here. Here's 950 for atmospheric pressure, and what we should see when we make our calculation by plugging 950 in for x, what we should see is a y value around maybe 107, 105, somewhere in there. So our prediction line, or our regression line, should give us a reasonable prediction value for 950 millibars. Now, that should be about it. When you are finished answering all the questions, please remember to attach all of your results, attach both the data sets that you worked with, and save. Once you do that, I want you to right-click and copy the URL and submit that through Canvas. If you have any questions, please let me know.